Here we have a problem on derivative. Okay, let's go to the question. If y equals to x to the third power over 1 positive x cube, find the derivative of y with respect to x to the fourth power. So here we have a function defined by y in terms of x, and we have to find the derivative of y with respect to x to the fourth power. So here the little trouble thing in this problem is x to the fourth power. So because if I want to find derivative of this y with respect to just x, I can easily do it. But here they're asking us to find the derivative with respect to x to the fourth power. So the trouble we have in this question is the exponent 4 we have for this x. Okay, so now what I'm going to do in the first step is I'm going to assign a new variable for this x to the fourth power. So that is, I assume let x to the fourth power equals to z. Okay, now let me take the original function over here, that is y equals to x to the third power over 1 positive x cube, and also we have assigned a new variable z, that is we have x to the fourth power equals to z. Okay, our aim is to find the derivative of y with respect to x to the fourth power, that is we have to find dy over dx to the fourth power. But we have assigned a variable, new variable z for this x to the fourth power. So instead of writing x to the fourth power, we can write z. So now my aim is to get dy over dz, that is I have to find derivative of y with respect to z. Okay, is it possible to find the derivative of the function over here with respect to z? No, it's not possible, because here y is a function of x. So I can find derivative of this y with respect to x. Okay, let me do it. So you can write dy over dx. And here x is a function of z. So I can find derivative of x with respect to z. So I'm getting dx over dz. So this is called chain rule. So our aim is to find dy over dx. So I started with dy in numerator and I ended with dz in denominator over here. So this is equal to dy over dz. Okay, to get dy over dz, that is a derivative of y with respect to z or with respect to x to the fourth power. So what I need to do is first I have to get the derivative of y with respect to x. So and then I have to get the derivative of x with respect to z from this function. So once I get the result for dy over dx and dx over dz, I have to multiply them to get the derivative of y with respect to z. Okay, so first let's get the derivative of y with respect to x. Here we have the function defined by y in terms of x, and I want to find derivative of this function with respect to x. That is, I have to get dy over dx. So when I find derivative of this y with respect to x, I'm getting dy over dx. On the right side, we have variable in both numerator and denominator. So when I want to find derivative of a function which contains variable in both numerator and denominator, I have to use coefficient rule. What is coefficient rule? Okay, let's consider the division of two variables u and v. I want to find derivative of this function u over v. So for that, in my first step, what I have to do is I have to square the denominator, that is v square. Okay, the same b should be taken over here. Now I have to get the derivative of the numerator u, then I'm getting u prime. Now I have to take negative sign. I have to take the numerator u as it is. Now I have to get the derivative of the denominator v, then I'm getting v prime. So this is called coefficient rule. We use coefficient rule in derivative when we find both variable in both numerator and denominator. Okay, now let's apply this coefficient rule in our problem. So here the first step what we need to do is we have to square the denominator over here, that is 1 positive x to the third power whole square. The same denominator should be taken over here. And now I have to get the derivative of the numerator, that is x to the third power prime. Now I have to take negative sign. I have to write the numerator as it is and get the derivative of the denominator, which is 1 positive x cube whole prime. Okay, so dy over dx equals to 1 positive x cube. And when I find the derivative of this x to the third power, I'm getting 3x square. I'm just using the power law of derivative. That is, I bring this exponent 3 in front of x and subtracted 1 from the exponent. Then I'm getting 3x square, negative x to the third power. So now I have to get the derivative of this 1 positive x cube. When I find the derivative of this constant 1, it will become 0. And when I get the derivative of this x cube, I'm getting 3x square using power law of derivative over 1 positive x cube, the whole square. Okay, now dy over dx equals to, okay, now we have completed the derivative, finding derivative process, so we have to simplify. So when I distribute this 3x square to 1, I'm getting 3x square, because 3x square times 1 is just 3x square. When I distribute this 3x square to x cube, I'm getting positive 3 times x to the fifth power. So here we have 3. When I multiply these two terms, x to the third power and x square, so both the terms have the same base. So I take the base ones, when I multiply them, I add the exponents, 3 plus 2, 5. Negative, so when I multiply this x cube and 3x square, I'm getting 3 times x to the fifth power over 1 positive x to the third power the whole square. So this positive 3x to the fifth power, negative 3x to the fifth power will cancel out. Then I'm getting dy over dx equals to 3x square over 1 positive x cube whole square. Okay, now I got derivative of y with respect to x. Now we can plug in this result for dy over dx into the original question. Okay, let's go back to the original question. Okay, here, so we got result for dy over dx. We can plug in for that result for dy over dx here. So let me write dy over dz on the left side. So for dy over dx, we know that just now we got the derivative of y with respect to x, that is 3x square over 1 positive x cube, the whole square. Okay, times, now I have to get the result for dx over dz. That is, in this function, I have to get derivative of x with respect to z. Okay, let's do this separately. Here we have the function x to the fourth power is equal to z. That is, so in this function, what we need to do is we have to find derivative of x with respect to z. Okay, so first let's find, okay, anyways, we find derivative on both sides with respect to z. So to get derivative of this x to the fourth power, what I need to do is, first I have to use the power rule. Power rule means I have to bring this exponent 4 in front of x and subtract 1 from the exponent. Then I'm getting 4x cubed. So far I've done derivative only for the exponent 4. By chain rule, I have to do further derivative for the base x with respect to z. When I find derivative of x with respect to z, I'm getting dx over dz. On the right side, when I find derivative of this z with respect to z, it just become 1. So because here in this function, my aim is to find the derivative with respect to z. So here, this is the result I'm getting when I find derivative on both sides with respect to z. Okay, our aim is to get dx over dz. So for that, we have to divide both sides by 4x cube. So I divide both sides by 4x cube. This 4x cube will cancel out. So I'm getting dx over dz equals to 1 over 4x to the third power. Okay, now I got the result for dx over dz. Now we can plug in this result for dx over dz into the original question. Okay, let's go back to the original question. Here we can plug in the result for dx over dz that we just got now. So that is 1 over 4 times x to the third power. Okay, now let's do the simplification work. So dy over dz equals to, so 3x square times 1 is just 3x square. And we can multiply the two denominators over here. So for that, first we can write this 4x to the third power first. Then I'm getting 4x to the third power times 1 positive x cube, the whole square. Okay, here, so z is a variable taken by us. It has to be replaced by the original stuff. Already we know that z equals to x to the fourth power. So we can replace the z by x to the fourth power. So dy over d of x to the fourth power equals to 3x square over, and 4 times, we can write this x cube as x square times x times 1 positive x cube, the whole square. So because when I multiply x square and x, I'm getting x cube. So I just split up x cube as x square times x because I just want to cancel out x square, x square. We can do this simplification. Okay, so dy over d of x to the fourth power equals to 3 over 4 times x times 1 positive x cube, the whole square. Okay, now I got the derivative of the function defined by y with respect to x to the fourth power. It is equals to 3 over 4x times 1 positive x cube, the whole square.